remember them having it for
I
modern
don't remember them
biology.
having it, but in any event, we don't
They
have
had pretty
records.
seismograph down, oddly
Okay,
enough.
so there are essentially two tricks that have been used to create the kind of data you have. They both have their limitations, but this is what we've got.
Yeah,
The
I'm
first
curious.
is a proxy system. It depends on picking a variable that you can show nowadays has a strong and hopefully as linear as possible relationship to temperature. And that you have records of some kind that extend back to the period you're interested in, and for which you have for the same place an overlapping instrumental record. So you have the record, say here, 1600 to 1800. Observation of when Lake Biwa in Japan freezes over. Observation of when the chrysanthemum blooms in Japan. When the wine harvest is in a particular area in France. All these kinds of things can be used as proxies. You also have ones that aren't dependent as much on what people were observing then. Ice cores, for example, where you can go in and measure gas slice up the ice core and measure tree rings. And actually a lot of this was tree ring based. Speleotherms, which are these cave deposits where they show a relationship
of climate to
climate.
Orbital mechanics to this?
You mean, when you say speleotherms, cave deposits, you mean like stalactites and stalagmites growing?
That's the
So they
generic
would
term.
grow depending upon the
if there's more moisture, they drip faster.
So they would get bigger in a drippier season.
That's criteria we moderns can
Corals,
refer to and measure.
lake sediments, they've done boreholes, and there were historical accounts. People obviously weren't saying it was 59 degrees today,
Right.
but today was a very cold day.
It's unseasonably warm.
What you did is you took these statements and you would go through the guy's diaries and lots of diaries, legal records, you name it, all sorts of things.
Newspapers.
And you would tabulate the words that they used, the phrases they would use to describe the record. And you would try to see where you were getting consistencies in time and place as to how it was described, and you would create a qualitative scale for those, which you then converted into a numeric scale. And those numbers, of course, did not have an absolute difference meaning, but as long as you had records going in to overlap with an instrumental record, you could try to correlate the two. Now, I'm sure by now you've recognized some of the dangers with these different types of proxies. The first is that what you're relying on
It's
could have
subjective.
changed so that the actual relationship you're establishing as the proxy relationship might not have been the same in the 1600s as the 1800s. Let's use the example of wine harvest. It was one of the first climate history studies by Laduri. And the trouble is that when you harvest the grapes, depends on how sweet you want them to be.
What kind of grapes
So
you have,
if the preference changed from a dry wine to a sweet wine, or from
Ice
a
lays
sweet
that,
wine
you
to a
freeze them
dry
all the way.
wine, it's going to affect the harvest date without regard to that.
Late. It's late.
Without
I know that.
going
I speak
into the
German.
details,
I lived in Germany.
people have tried various tricks for accounting for these kinds of factors. Now, if I had 10 different climate reconstructions for the 1630s that had this kind of geographic mapping of Europe available, I would have had to, and they were in sharp disagreement, I would have had to look at the nitty-gritty of how they did the reconstruction and decide which I thought was more valid. But if there is only one, then that's what you go with unless it looks completely insane. And so we have the work of Lauterbacher and Zoblocki in Europe and other people elsewhere. And so that's pretty much what I ran with. Their work, but the second factor you have to worry about, we can use proxies. There are a lot of proxies that would not work. If a proxy is measuring something where the change works on a decade or multi-decadal basis, then while that may be very useful for understanding climate change properties that are on those scales or on century scale, it's not going to help me figure out whether 1636 was a warmer or colder period than 1637. So I needed to look only at the ones that had an annual or near annual resolution. And that's things like tree rings, for example. And I believe, if I recall correctly, Lauterbacher worked most on a combination of tree rings and documentary evidence with occasional consideration of other stuff. You go to other parts of the world, they liked other things. Like for Southern Africa, the speleotherm data is the best data available.
They don't have as many trees.
If you look up in Greenland, they have even fewer trees. And so it's mostly the borehole stuff, the ice core stuff, I mean to say.
Moss layers.
That's right. And so you have these different groups. But that's where I got the monthly data, which I don't have. The grids are far beyond the ability of Excel to handle. We're talking about 30,000 or so columns and the like when you get for some of the stuff. But I did extract some data for the particular locations of Granville and Magdeter, but I unfortunately had problems in that the monthly data was all given as anomalies, and they didn't bother to get, well, they stated the reference period, but they didn't bother to give the actual reference numbers, which I then had to reconstruct from other sources. But let's take a look at some of these graphs, since it's always more fun to have a slideshow. When we dim the light, if we can.
Yeah, switch the light off.
Nobody can prove you were wrong.
Okay, it was cold last week.
Yeah,
Okay,
that's perfect.
this is 1630 to 39 average together using the Lauterbacher Explorer and running it through Lauterbacher data and running it through Climate Explorer for the whole year versus 1990 to 1999. And one thing that I found curious is that except when you look closely, look at the boundary areas, and bear in mind that these are artificial gradations. We're choosing to use a particular color for a particular range of temperatures, and it's really, you know, a more gradual transition. But you can see that it's shifting things, but not as dramatically as you might expect. As I said, the winter 1635, it was a cold winter, but of the period 1500 to 2004, it ranks using Lauterbacher's data as the 30th coldest winter. It would not have, there would be people who alive in 1635 who would remember colder winters than that one and would complain about all the sissies at that period. Now we look at December, January, February, which is the winter, December 34 to February 1635, and actually you can see much more substantial differences in where things are here than you did before. If you look up in Scandinavia, how that dark blue area, which is under minus 15°C is the main, how that spread. And look, for example, at northern Germany, how it's the gray area, which is -3 to +3 in 1630-39 average, and it's the 3 to 6 range in the next. So you're seeing shifts more at this time scale. When we go to the spring, we see some shifts again, perhaps not quite as dramatic, but look, for example, southwestern Spain. And then here, we're up to September, October, November, and you really have to search to see any difference at all.
Hey, Ivar,
Yes?
is there any indication that the Gulf Stream will change course?
Conveyor?
There, we don't have,
I mean, you know, that puts most of the heat into Northern Europe.
I don't know if anybody
we
back at that
don't, there
know
have
what it
been
was
studies
measure.
of the North Atlantic Oscillation,
Yeah.
which affects how storms, whether storms head toward Northern Europe or Southern Europe, it affects the steerings of storms. But the trouble is, there's no
record.
good proxy for them to use that I can think of to give them any idea of the Gulf Stream. Even today, our information in the oceans is a lot sparser than our information on land. And now, here, yeah. And then I decided to take the coldest and warmest years for a particular season. So there's 1635 winter on the left versus 1630 winter on the right. And you can see some shifting there. The scales are the same, but these scales are not the same as for the earlier set of graphs, which used a completely different program. Yes?
Maybe I missed what you said. Are these the average daily temperatures or the average highs, the average
These,
lows?
well, first of all, we don't have any high or low
Yeah.
temperatures until much later in history, nor do we have a proxy for them. So they can't be reconstructed at all.
So
these are seasonal average temperatures, but they're the results of, for example, think a tree ring. During the growing season, how much growth accumulated. So any particular day, it's going to be affected by temperature, but we don't know which for any given day. The best we're getting is the seasonal data for the growing season.
Is probably what's happened with your average growing season length.
That's right. And we do that, and my guess is that for the winter data, we're looking more at those diaries and that kind of evidence, because that's outside the growing season.
Well, yeah, but
it's-
even outside the growing season, you can see damage. You know, on
frost
certain,
damage.
lots of tree rings will show that the tree almost died here because the winter was so cold.
Exactly. And now here where we go to March, April, May, 1635 is again the winter on cold, and this time